Hello everyone, welcome to our channel Mathematics Pathshala. This is a problem of CSIR UGC NET June 2024 Mathematical Sciences. This is a question from Linear Algebra Part C. The question ID is 704074. First we read this question. Let A be a 4 by 4 real matrix whose minimal polynomial is x squared plus x plus 1 and let B equal to A plus I4. Which of the following statements are necessarily true? Option 1 says that the minimal polynomial of B is this, and option 2 says that the minimal polynomial of B is this. So we have to find the minimal polynomial of B. So see here, the minimal polynomial of A is given that x square plus x plus 1. So this is equal to x minus omega into x minus omega square, where omega is a cube root of unity. So this is very clear that the minimal polynomial is a product of distinct linear factor over C. So A is diagonalizable over C. So A is diagonalizable over C. Now now we have B is also diagonalizable over C, because when A is diagonalizable, then we have P inverse AP equal to some diagonal matrix D. So from here we can easily prove that P inverse BP is also a diagonal matrix. P inverse BP is P inverse B is A plus I4. We are writing simply I P. So this is actually P inverse AP plus P inverse IP, that is P inverse P. So this is D and this is I. So both are diagonal matrix and their sum also a diagonal matrix, say D1. So we have B is diagonal matrix over C. So the minimal polynomial of B is also the product of distinct linear factors, and also the eigenvalues of B clearly eigenvalues of B are clearly uh, omega plus 1 and omega square plus 1. As B is A plus I, we know that the eigenvalues of B will be the eigenvalues of A plus 1. So the minimal polynomial of B must be, this is actually omega plus 1 is minus omega square, and omega square plus 1 is minus omega. So the eigenvalues of B are minus omega square and minus omega. So the minimal polynomial of B is clearly x plus omega into x plus omega square, and that is equal to x square minus x plus 1. So here option 1 is not the correct option, option 2 is the correct option. Now look at option 3. The eigenvalues of BQ, the eigenvalues of B are minus omega square. So eigenvalues of B cube are minus omega whole cube and minus omega square whole cube. That is minus omega cube, that is minus 1, and minus omega to the power 6, that is also minus 1. So the two eigenvalues of B cube are minus 1 minus 1. So B cube cannot be I4, as all the eigenvalues of I4 are 1. So option 3 is not the correct option. Now look at option 4. Simply if we calculate B cube plus I4, then B is actually our A plus I4. We are simply writing A plus I whole cube plus I. So simply this will be A cube plus 3A square. This is not the formula of A plus B whole cube. Simply just using distributive law repeatedly we get this 3A square plus 3A plus I. So this is A. If we take common A, then we get A square plus A plus I plus also 2a square plus 2a plus 2i. So this the the minimal polynomial of a is this x square plus x plus 1. So we have a square plus a plus I equal to 0. So this is a into null matrix. And also if we take common from a, we also get a square plus a plus I, that is also a null matrix. So ultimately we get this is 0. So bq plus I equal to 0 is the correct option. So here only 2 and 4 are the only correct options. This is the solution of this problem.